Hello, my name is Renato Cotti. I'm working as a product manager for neuroimmunology products at Bühlmann Laboratories in Switzerland. Today I would like to present to you just one of the series of the products, namely the Bühlmann GanglioCombi Light ELISA. Now, Bühlmann GanglioCombi Light ELISA comes with all the reagents and the pre-coated microtiter plate. There is a calibrator and a set of 3 controls of 3 different titer levels. These reagents are lyophilized and have to be reconstituted with buffer. All other reagents are ready to use. The substrate, stop solution, and 3 enzyme label conjugates, IgG, IgM, and IgG-M mix, and finally the wash buffer. Now, on Bühlmann GanglioCombi Light ELISA, there is 3 major gangliocytes which are coated onto the microtiter plates, namely GM1, GD1B, and GQ1B. Why these gangliocytes? First of all, GM1 is the most frequent gangliocyte found in human body. GD1B shares some similar structures with GM1 and may cross-react with GM1. And finally, GQ1B is the most specific gangliocyte and is related to a very specific syndrome, which is the Miller-Fisher syndrome. GQ1B and its some structures are similar to GD1B. So GQ1B is expected to cross-react with GD1B occasionally. Now, the gangliocyte antibodies exhibit a couple of key features. First of all, there are 2 isotypes which are involved. IgG antibodies are predominantly associated with acute neuropathies, and IgM antibodies are predominantly associated with chronic neuropathies. Finally, technically speaking, there are 2 properties of antigangliocyte antibodies. First of all, they are code-reactive. This means for the assay, it needs to be done at cold incubation steps. Secondly, they are slow reactive. This means it needs appropriate reaction time of the serum. What is the intended use of antigangliocyte antibodies, GM1, GD1B, and GQ1B in particular? First of all, they can serve as a screening, a targeted screening against the most frequent gangliocyte antibodies. And they can also give clues and reveal an etiology of an autoimmune background. Just remember, there are more than 500 causes behind a peripheral neuropathy. And now I would like to explain to you the microtiter plate architecture of a Bühlmann GanglioCombi Light ELISA test. You see here the plate and 12 columns, and here in A and B, and in C, D, and E, horizontal wise, are different gangliocytes, GM1, GD1B, and GQ1B. The gangliocytes, the same order is repeated again below. The A and B rows are meant to be for calibrator and 3 controls of 3 different titers: medium titer, low titer, and negative. These just perform to have a control of the assay performance. With the IgG conjugate, you can pipette in a pattern as this. At least 4 patients are used, which are here. And these are the IgG results. Then next to the IgG, there is the same gangliocyte antibodies again, but with IgM, which are related to chronic neuropathies. Now with one GanglioCombi light plate, you may run as many as 12 IgG and 12 IgM, or then if IgG and IgM are not relevant for your work, you may run an IgG-IgM mix instead. How are the results of a GanglioCombi light plate calculated? Now the results are expressed as percent ratio. In order to do so, you have to take the OD values and compare them with the OD value of the calibrator. For the mix, this ratio is multiplied with 200 and results in a percent ratio. The same procedure can be applied for the IgG and IgM conjugates, but instead of 200, you multiply with the factor of 100. The percent ratios as an outcome of the calculation here can be divided into different titer categories. The category between 0 and 30% is negative. The gray zone is between 30 and 50%. The cutoff is here at 50%, and above the cutoff between 50 and 100%, the samples are positive, and when they are exceeding 100%, then the sample is highly positive. There is a color code, which is red, yellow, gray, and white. White for negative, gray for gray zone, yellow for positive, and red for highly positive values. What is the principle of the assay of a Bühlmann GanglioCombi light assay? You see here a single well, which is coated with the gangliocyte here in the blue color, and here the sialic acids. Now, first of all, when the plate is unpacked, the plate has to be washed with cold wash buffer. In a second step, there is a first incubation where the patient serum is added to each of the wells. This step has to be done at between 4 and 8 degrees. Afterwards, the plate is washed again, unbound antibodies are removed, and there is a second step with the second antibody, which is HRP conjugated. This step, this incubation step, is again done for 2 hours at 4 to 8 degrees, and afterwards washed again with wash buffer. Finally, the TMB substrate is added. This step, important, has to be done at room temperature, and also the TMB substrate has to be used at room temperature. And after half an hour, this reaction from blue to yellow has to be stopped with a sulfuric acid, which stops the process here. The results and OD values are then read at a conventional wavelength at 450 You can find more information on the assays on biermannlabs.com or biermannlabs.ch.